precise definition of a limit. So let's recall that the distance between x and a is written by absolute value x minus a. That should be pretty much straightforward. If you have a number line and you have numbers 0, 1, 2, 3, how do you calculate the distance between 2 and 3, I'm sorry, 1 and 3? You would take 3 minus 1, right? 3 minus 1. And we have the absolute value to denote that distance is positive. Because if you go the other way, minus 1 or minus 2, minus 3, you would subtract minus 3 minus 2 and you get negative number. In that case, to keep distance positive, we have the absolute value. So this is the notation. X minus a is the distance between x and a. And if we are clear on that, then the distance between f of x and L would be the same way, absolute value f of x minus L. Now, in mathematics, very, very small numbers are denoted by Greek letters, and so we just choose them epsilon, epsilon, and delta. So the epsilon is written like epsilon, like an E the other way. This is epsilon, and the delta is written like delta, small delta. So those ones are Greek letters chosen for denoting small, small letters. It's customary used in mathematics. Now, definition of a limit. If f is a function defined on some open interval that contains the number a, except possibly at a itself, then the limit as x goes to a, f of x is equal to some number L, if for every epsilon, for every very small positive number, for every epsilon greater than 0, there exists a number, small number, delta, positive number, such that distance between x and a is less than delta, then if the distance between x and a is less than delta, then the distance between the function and the limit is less than epsilon. In other words, the limit means that the distance between the function and the value of the limit can be made arbitrarily small by taking the distance from x to a sufficiently small, but not 0. Take notes, and I have picture on the next slides. I will explain this. All right, so now I'm gonna move on to the next slide. And here, I rewrote the definition right here. So this is limit as x approaches a, f of x. If for every epsilon, there exists delta such that the distance is right here. So here, please try to understand this. X minus a, if you have absolute value x minus a is less than delta, right? By definition of absolute value, this can be positive or negative. So we have x minus a is less than delta and greater than negative delta, right? If we would like to solve regular way. Then I could add this a to both sides, to a plus a plus a to all the sides. And what I'm getting that x is less than delta plus a is less than minus state or a minus delta if you want a minus delta. And that stuff we have right here. If this is a number a, you adding very small value. So this is the adding small delta. So where you gonna be? A plus delta. Or you subtracting the same small value. So what you gonna have? A minus delta. Questions? And exactly the same way we could solve this part, and we would be in this spot is the number L plus epsilon, and in this particular spot it would be the number L minus epsilon. Yes. So in that case, if you choose for every value of x, you pick x here, that the distance between a and x is less than that delta if for any x minus a, the distance is less than delta, then for any value of epsilon, the value of the function and the value of the limit, they are close to each other. So this is the function, this is my limit L. The values are very close to each other. The distance between them is less than the given epsilon. Questions? We have a question. So proof that limit as x goes to 2, 2x plus 5 is equal to 2x plus 5. And I rewrote the definition right here so we can see what we have. So the limit as x goes to a, f of x plus f of x equals to L. If for every epsilon there exists delta, such that those two inequalities hold. So first thing what we need to do is to identify what is my A. This is my A, so the A is 2. My f of x is this function, right? And this is my L. And what we need to do, the proof goes in two steps. Number one, we need to find delta such that x minus a less than delta. If fx minus a less than delta, then f of x minus L is less than epsilon. We can write using our numbers. So a is 2, so we have x minus 2 less than delta, and our f of x, we're gonna go with the f of x. So f of x minus 5 must be less than epsilon. So we start looking for this by solving this, manipulating this equation until we get to the given what we have. So if I started with the f of x minus 5, I substitute my f of x. So we have 2x plus 1, this is my f of x, minus 5. That gives me absolute value 2x minus 4. I need to get to this, what I have on the side, so x minus 2. So we can take 2 out. If I take 2 out, I have x minus 2. Now, this is equivalent to what we started, f of x minus 5. And we know that f of x minus 5 must be less than delta. So absolute value f of x, actually, I want to write it down. I want to write it down, my f of x, which is 2x minus 2. This must be less than delta. So then we need to compare what delta should, I'm sorry, less than epsilon. Then we need to compare what delta would be. I divide both sides by 2. So I have x. I have x minus 2 less than epsilon over 2. And then if we compare what we have with what is here, we can see that this is my delta, right? The delta is gonna be defined as epsilon over 2. So delta is equal to epsilon over 2. We let this delta. That's how we find the delta. This is the first step. And then we need to prove that this delta works. So let me clear this. I'm gonna rewrite my delta was epsilon over 2. I'm gonna rewrite what we had. This one was my A. f of x, and this is my L. All right. Step 2 would be prove or show that your delta, in that case we have epsilon over 2, works. That is, if absolute value x minus a is 2, is less than delta, then absolute value f of x minus 5 is less than epsilon. So in other words, we assume that this holds and prove that this is true. So we're gonna start with this part. So take this f of x minus L, that's what I'm gonna start first. This L, I know that is 5, right? So now I substitute f of x, which is 2x plus 1. You can put parentheses if you like, that's fine. Then I have minus L, my L is 5, equals, collect like terms, so we have 2x minus 4. We can take the 2 out of the bracket, 2x minus 2. And now we apply what we know. We apply our assumption. So we know that this 2x, absolute value 2 minus x is less than delta. So everything is less than 2 times delta, because this part is less than delta from the given, what we have given right here, right? Now I substitute what my delta is. My delta is epsilon over 2. So I have 2 times epsilon over 2, which is epsilon, because those ones cancel out, right? And then if we look at the beginning, we started with this. This is equivalent, equivalent, equivalent. We have less than, equivalent, equivalent to epsilon. So what I showed is f of x minus L is less than epsilon. And that's what was needed. So the proof is completed. Our next example is proof this statement using epsilon and delta that limit as x goes to 4, 1/3 x minus 2 is equal to negative 2/3. If you would like to calculate that limit, we can certainly substitute for, take the 4, substitute for x and perform the calculations, and we will definitely get negative 2/3. So the limit indeed is negative 2/3. I rewrote this question right here using statement because I would like to see the definition. So first, as before, we're gonna identify what is my A. My A is 4. What is my f of x? And what is my L? And as before, we have 2 steps. Number 1, find delta. Find delta such that if absolute value x minus a, my a is 4, is less than delta, then f of x minus L, negative 2/3, must be less than epsilon. And we start with this one, manipulate this formula until we get in this form to see what the delta would be. So absolute value f of x minus negative 2/3 is equal absolute value 1/3 x minus 2. This is my f of x. Now I have minus negative 2, it's plus, not minus negative, minus negative 2/3, it's plus 2/3. Find the common denominator. So this is like over 1 times 3 times 3. So what we have is absolute value 1/3 minus 6/3 plus 2/3, 1/3 x, of course, I forgot, is equal to 1/3 x, negative 2/3 plus 2/3 is negative 4/3. And then I need to go to get x minus 4. That's the goal to identify. So if I take 1/3 out, so this is equal to take 1/3 out, and what we have left is x minus 4. So now f of x minus negative 2/3 must be less than epsilon. So my thing must be less than epsilon. So I'm going 1/3 x minus 4 must be less than epsilon. Perform the operation. So times 3 times 3. This cancel out. So what we have is absolute value x minus 4 is less than 3 epsilon. So three epsilon. So if we look at what we have, compare this with what we just received, we can clearly see that my epsilon, sorry, my delta is nothing else but 3 epsilon. That's how we can define let delta equals 3 epsilon. And that's my first step. Now, second step, we do need to show that the delta, what we chose, works. So let me erase the board. And we have second step. Number 2, show that the delta was 3 epsilon works. That is if, and we rewrite the definition as x minus a, my a was, this is my a, this is my f of x, this is my L, right? X minus 4 less than delta, then f of x minus L, which is minus negative, so plus 2/3, must be less than epsilon. So to prove it or show, so prove or show, that means we assume this, and we need to show that this holds. So we're gonna start with the f of x minus L, f of x minus L equals, substitute, what is my f of x? F of x is 1/3 x minus 2 minus negative 2/3, which is plus 2/3, right? Minus negative 2/3 equals absolute value 1/3 x minus, change this to thirds. So 1 is 3/3, 2 is 6/3 plus 2/3. Or you can find common denominator as before. So we have absolute value 1/3 x minus 4/3. Now take 1/3 out. So we have 1/3. Maybe I'm gonna write in the next line. So we have 1/3 out, x minus 4. And this now x minus 4 is less than delta. So we can make it less than delta. That's my x minus 4. So everything is less than, and I have 1/3 times, between them is of course times, this is less than delta, so delta. Now, my delta is 3 epsilon, right? So we substitute that this is 1/3, we had 1/3 times 3 epsilon. So 3 epsilon cancel, 3 and 3 cancel out, and I am left with epsilon. So then look at the beginning, what we started with. This is equivalent, 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 less than, to equivalent stuff. So what we show is f of x minus L is less than epsilon. And that was required of us to show. So the proof is completed. In similar way, we define the left hand limit and right side limit. So limit from the left side, if for every epsilon there is a number delta, such that the x is taken from the left side only. So from the left side, if we go back to the first slide, from the left side is right here. So we see a minus delta and a. So the x is between a minus delta and a, then the distance between function and the limit is less than epsilon. And from the right-hand side, definition of the right-hand limit is similarly, we take the x from the right side of the limit. So any x between a and a plus delta, then the distance between the function and the limit is less than epsilon. And the same would be definition of limits, infinite limits. So if the limit is infinity, then of course the distance between function is gonna be greater than some big, big, big positive number for every x minus a less than delta. And similarly for minus negative infinity, the limit is negative infinity, the value would be less than some negative big. For every negative number, the value is going to infinity.